This video will introduce you to the idea of even and odd functions. When we talk about even and odd functions, it's easy to get this confused with the idea of even and odd numbers. It's slightly related, but this will make a lot more sense if you think of them as entirely separate from the idea of an even or an odd number. The first place we can see the difference between an even and an odd function is in their graphs. And it all has to do with the symmetry of a graph. So here you see four different pictures of graphs that have some sort of symmetry. The first one here is probably the hardest to see, but it has what's called symmetry about the origin. This means that if you take the coordinates of any point and then you take the opposite, so make positive coordinates negative and negative coordinates positive, that point is also on the graph. This would work for any point. So for example, here we have 4, 0, and negative 4, 0 is also on the graph. The second type of symmetry shown here is symmetry across the y-axis. You can almost see that if I took the left side and reflected it over the y-axis, I would have the right side. So I could also take any point and just reverse the sign on the x, and that point will also be on the graph. So keep y the same, but flip the sign on the x, and that point is also on the graph. I'm going to skip down to the bottom left now, and you can see some x-axis symmetry. If I take the top and reflect it over the x-axis, I have that bottom part. And this time, if I take a point, I'm going to take the opposite of the y, and that will also be on the graph. The last example here is symmetry across some other line. In here, I've drawn in the line x equals 1, and you can see if I reflected either half across x equals 1, I'll get the other side. So what does this have to do with even or odd functions? Symmetry about the origin is called an odd function. So any graph that has this type of symmetry is called odd, and symmetry about the y-axis is called an even function. So any graph that had that quality would be considered even. You'll notice this one on the bottom left is not even a function, so we aren't going to consider those. Any graph with symmetry across the x-axis would not be a function, so we're not going to consider those. And this has no special name, so we're also not going to consider that type of symmetry. So now that we know what even and odd functions look like in graphs, let's consider equations. Remember that I said that an even function is symmetrical across the y-axis. It's very important to note that both x and negative x give the same y value. So if I took 1 and negative 1, they are both going to give me the same y value, and that's really hard to see, so let me change the color. But 1 and negative 1 have the same height. So a good way to check is to pick a number. So I said here, pick 2, take the opposite, so negative 2, plug both into the equation, and see if you get the same number. So there's an example down here at the bottom of y equals 2x squared. So here on the top I plugged in negative 2, and I did 2 times negative 2 squared, so that would be 2 times positive 4, so that's 8. And 2 times positive 2 squared is also 8. So since I got the same number out, when I plugged opposite numbers in, it's an even function. Let's look at another example now. So I've taken pretty much the same equation, but tacked on this plus x at the end. So here again I did y equals 2 times negative 2 squared plus negative 2. So that is going to equal 8 minus 2, so that will be 6. This bottom one, again, this part is an 8, so now we have 8 plus 2, and that's 10. So since I got different answers, this is not an even function. Now let's look at figuring out if something is an odd function based on the equation. Again, remember, an odd function has symmetry about the origin. So if I pick any x, let's say this is 2, and find the y, so let's say that's 2, 5, I could go to -2, and the y would be -5. So opposite x, opposite y. So here, if we're going to check it with an equation, again, pick a number. So again, I said 2, take its opposite, so -2. Plug it in and see if you get opposite answers. So here my equation is y equals x to the third minus x, and I plugged in -2 for my x's on the top and then 2 down here. And in the first one, I ended up with -8 plus 2, so that was -6. And then in the bottom, I ended up with +8 minus 2, so that was a +6. And since I got opposites, 6 and -6, I know that this is an odd function. Let's look at one more example. Now I have y equals x to the third minus 2. So I plug in -2 and +2. Let's see what we get for answers. Up on the top, we're going to have a -8 minus 2. So that will give us a -10. And then on the bottom, we have a +8 minus 2, which gives us a +6. These are, though they have opposite signs, not actually opposite of each other because we have a +6 and a -10. So this would be not odd. In fact, it's neither odd nor even. So for homework, I would like you to try these 6 problems. Try plugging in a number and its opposite and figure out if it's even, so you get the same number out, odd, you get opposite numbers out, or neither, meaning you get 2 completely unrelated numbers. Good luck.